right, hello, how are you doing? We are continuing our practice for the free response questions. This is the 2016 question number 3. You're going to notice it's the same type of question as the other two. We have a graph that has 6 straight line segments. So they make a bunch of triangles, which is nice. And g is defined as the integral from 2 to x. Now this 2 is going to be very important to us later, and I'm going to show you why. Well, I'm going to show you why when we get there. But I want to tell you why I put this dotted green line here. That dotted green line is kind of our starting value. Almost think of it as when we do an antiderivative, that plus c. That plus c kind of gives us a value where we should start. So it's similar to that. I also put the dotted lines at the end because this is going to become handy a little bit later on. Okay. Let's start answering the questions. Does G have a relative maximum or relative minimum or neither at 10? And the big thing is justify our answer. Well, let's find the answer first and see what we can go from there. All right, does G have a relative minimum? So if G has a relative minimum, we find the derivative of G and find out if it equals 0 or if it doesn't exist. Then it could be a critical number. Okay. Well, if G is defined as the integral of f, then I know that G prime equals the derivative of the integral. And by the fundamental theorem of calculus, that's just f. The derivative and the integral are inverses of each other. Now, we're going to use this one later, so I'm going to put it in there now. If I take the next derivative of G, the second derivative of G, it's the same as the first derivative of f. That's how all these are going to relate in this graph. Okay, but let's get back to this specific case. Is G prime of 10 equal to 0? Now G prime of 10 is the same as f of 10. And here's f of 10 right here. Is it equal to 0? It sure is. It's smack dab on the x-axis. That means it's potentially a max or a min. So we use the first derivative test. We're going to test G prime. But remember, G prime is f. And this is the graph of f. So right before 10, what are the values? The values of this graph are negative. Past 10, the values of this graph are negative. Okay, we're not looking at the slopes, we're looking at f of 10 itself. So this means that G of 10 is neither a max or a min. Now, in past AP tests, and this has been quite a while, maybe when I first started teaching or so, not quite that old, but this would be a fine justification for the answer. However, the AP people want to know that you understand what this means. You have to write it out in words for them. So G of 10 is neither a max nor a min because, and the reason why, it's going down, it levels out, and it goes down. In order for this to be a max or a min, there has to be a sign change, either going down and up or going up and down. Well, guess what? There's no sign change. So you can say it that way. Because there is no sign change. At 10. At 10. Okay. All right. Does G have a point of inflection? Points of inflection are second derivatives. And as we said earlier, second derivative of G is the same as the first derivative of f. So we have to analyze f prime of 4. Now f prime of 4 is up here. Now there's f prime, so we're talking about the slopes of f. Well, is the slope 0? No. What is the slope? The slope does not exist. The slope doesn't exist because you can't go from a positive slope instantly to a negative slope. There's no derivative at a point or a cusp. So f prime of 4 does not exist. So therefore it's a candidate for potential point of inflection. So we test the second derivative. But don't forget the second derivative is the first derivative of f. And first derivatives tell you slopes. Look at the slopes. So before 4, the slopes are positive. After 4, the slopes are negative. So if we go from a positive concavity to a negative concavity, that's what we call a point of inflection. So yes, G of 4 is a point of inflection. Because, and it's kind of the opposite reason from the last time. There was no sign change, so it wasn't a max or min. Well, guess what? There is a sign change, so it works. Yes, see, because G prime of 4 goes from positive to negative. Okay? And that's a fine answer. That's your justification. All right. Absolute minimums and maximum values. So if we talk about absolute minimums and maximums, we're looking for critical numbers and endpoints. So critical numbers. So the critical numbers of G, and here we go again, G prime is the same as F. We want to know when this stuff equals 0. When is F equal to 0? Because when F is equal to 0, G prime of X is equal to 0. And we have 4 points. We have -2. We have 2. We have 6. We have 10. These are all values where we can have potential maxes and mins. But we also have to check the 2 endpoints. Now, to make it a little bit easier, we could figure out that there's some of these that actually won't fit in these critical numbers. So if you look at -2, and we're looking at F, it goes from negative to positive. So that's critical. I mean, that's a max or a min. So negative to positive. So negative to positive means it's a minimum. Right? At 2, it's positive and positive. Oh, well, if it's positive and positive, it can't be a max or a min. At 6, it goes from positive to negative. So positive to negative means it's a maximum, a local maximum. And at 10, it goes from negative to negative. So it can't be a max or a min. So we have to find these values, and I'll put them in order. All right. Now we're going to calculate these. And I'm going to be honest with you. We're going to start with an easier one. Because, all right, so I have to calculate these values. Now I want to start with G of 6 because it's a little bit easier to visualize. So remember, G is defined, and here's where that 2 comes in. It's very important, from 2 to x. So this will be from 2 to 6. All right. So remember, it's defined as area. So what's the area from 2 to 6? Well, the area is all of this. Okay, and we can calculate that area very easily. That area is 8. Because it's a triangle with a base of 4 and a height of 4. And 4 times 4 is 16. Half of 16 is 8. So with that in mind, let me calculate this. That's -8. It's negative because it's below the axis. This is -4. This is 8, and this is -4. Okay. Let's use that now to figure these things. So from 2 to 6, what's the area of this thing from 2 to 6? It's 8. Now with that in mind, what's the area all the way to 12? Well, we added 8. Again, we're always starting from 2. This is from 2 to 12. So we had the 8 here. But now this 8 is below the axis, so we take that 8 away. And now we take away even 4 more. So this value is negative 4. Now the reason I wanted to start with these, it's easy to think about stuff in the positive direction. Now we're going to think about going this way. All right. We still start at 2, but we're going the opposite direction. So basically, we're going from 2 to negative 2. Now, if you remember, we had a little identity, a little definition there, that if we switch these, we change the limits of integration, we flip them around, then our answer is opposite of what it used to be. So from negative 2 to 2, we have a value of 8. But because it's opposite, it'll be negative 8. Now I want you to think about this also in a different way. If I start here and I'm going backwards on the graph, then everything's going to be in the opposite direction. So instead of being a positive 8, it's going to be a negative 8. So it's another way to think about it. So for 4, we're going to go from 2 to negative 4, which if you remember, if we flip it around from negative 4 to 2, well, what's the area from negative 4 to 2? Well, it's 8 minus 4, which is 4, but it's going to be the opposite. Okay? Or if you think about it again going backwards. If you go backwards, it's 8, but because we're going backward, it's negative 8. And then negative 4, but because we're going backward, it's positive 4. So what's negative 8 plus 4? It's negative 4. So here we go. Our absolute maximum value is that one. Our absolute minimum value is that one. Now just to save time, I won't write it out, but really you should write absolute max at g negative 2 is negative 8, and absolute min, and absolute max is g of 6 or 8. Okay, you should write that. And that's going to be in the rubric that I gave you, but just save a little bit of time because we have one more question to go. And it can be thought of logically, and it can also be calculated. So let's do I don't know, we're going to do the same principle that we did last time. We're going to talk about directions and see if we can calculate these. Okay. So what intervals is g negative? Okay. So g, remember, is the integral from 2 to x. So if we think about it this way, we already calculated what is g of negative 4. Okay, we calculated it back here. G of negative 4 is negative 4. Now, what's going to happen? Yeah, let's look at the next one we got. We said that g of negative 2 is negative 8. So guess what? So we got a little bit more negative. Now, what's going to happen here? Or think about it this way. What would g of 2 equal? You don't have to think about anything. G of 2 is right here on the point. What's the integral from 2 to 2? Right? Well, there's no area there. So remember, by definition, that is 0. So notice how g of negative 4 is negative 4. G of negative 2 is negative 8. And then if we're traveling this direction, we're putting 8 back on. So when we get to 2, we're back to 0. So everywhere from negative 4 to 2, g will be negative. Now think about it. When we're traveling this way again, we're adding. So g of 2 is 0. G of 4, g of 6, I'm adding all of this on. Remember, g of 6 was 8. And I'm going to keep on going, though. What's g of 10? So I added 8 to it, And then from 6 to 10, I'm taking 8 away. I'm back at 0, which means g of 12 is under the axis. So it's -4. So hopefully you can see, when is g prime, oh, I'm sorry, when is g less than or equal to 0? On 2 intervals, from -4 to 2, and then starting at 10 and going to 12. All right, so that was a little trickier, I know, a little bit more to think about. But if you start thinking about these problems and putting them together, they start to make sense. So those are 3 problems so far. Again, we'll do more. I'll put the other ones up there. But in our live sessions, we can talk about these problems and see where any troubles might be so we can fix them. So that's it for now, and I'll see you later. Bye.